Hi, this is the Science Chef. In this video, we'll be showing you how to answer questions on the Cambridge IGCSE Chemistry Paper 4 for May-June 2020. We'll be starting with question 1 because we'll be answering the questions in part. This question is about elements X, Y, and Z. One thing about IGCSE is that this introductory statement always gives you information about the question. So from this statement, you can know where the examiner is going. You are told that this question is about elements, right? Now, which means that you are expected to have the basic knowledge about elements. Not just elements, but also what? Atoms. Fine. So let's start. Let's look at this. It says an atom of element X is represented as this, X3416. Now from this representation, this is, you have X3416. Here, X is the nucleon number. Sorry, 34 is the nucleon number, while 16 is the atomic number. And the atomic number is also known as what? The proton is the proton number. That's the number of protons in the nucleus of an atom. Well, this is the sum of the protons plus what? Neutrons in the nucleus of the atom. Fine. So we are told to do what? Name the different types of particles found in the nucleus of this atom of what? X. Now, in an atom, what are the particles present in an atom? In an atom, we have what? The protons, neutrons, and electrons present in the atom of an element, right? Now, the protons and neutrons are collectively known as what? The nucleons. Why? Because they are found in the nucleus of the atom, while the electrons revolve in orbits round the what? The nucleus. In other words, if we draw this as, if this is an atom, this will be the nucleus of the atom, while this will be the shell or orbit. So from this shell or orbit, this will be the electron. This will be the electron, while this will be the proton and neutron. Protons and neutrons will be found here. So now we are going to use this structure to answer this question. Name the different types of particles found in the nucleus of this atom of what? X. So for this atom of X, the different types of particles found are what? Are the protons and what? And the neutrons. And collectively, they are known as what? They are known as the nucleons. Collectively, they are known as what? The nucleons. So it means that the nucleons are the subatomic particles found in the nucleus of an atom. Take note of that. The nucleons are the subatomic particles found in the nucleus of an atom. They are subatomic particles found in the nucleus of an atom. Fine. So remember, you have 2 marks here. 2 marks here. So 1 mark for each. 1 mark for the protons, 1 mark for the neutrons. Fine. So moving on. The next question says, what is the term for the total number of particles? What is the term for the total number? Now, total number of particles. What is the term for the total number of particles in the nucleus? So the position, the location of the particles is stated. The term for the total number of particles in the nucleus. Now, since we need the term, since they need the term, and this is what they are looking for, not the term for the particles in the nucleus of an atom, but the term for the total number. So like we had already stated here, this is the total number of particles, right? total number of particles in the nucleus of an atom, and it is known as what? Nucleon what? Number. Nucleon number. You can call it nucleon number or mass number. Nucleon number or mass number, right? So, and of course, which is what? The total number of protons and neutrons present in the nucleus of an atom, right? At times they may not ask you a question on the nucleon number, they might ask you a question on the atomic what? Number, which is what we have already stated here. This is what we already stated here, that it is the total number of protons in the nucleus. You must always add that nucleus. In the nucleus of an atom, you must always add the location, because that question always comes as 2 marks, right? So first off the definition and then the location, so 1 mark each. So for this particular question, we are asked for the term, to give the term for the total number of particles in the nucleus of an atom, and that is what? Nucleon number or mass number. So let's move on. Next question says, what is the total number of particles in the nucleus of a now? Question 1II was the term. Now they need the total number, which is a value, right? So from our initial analysis here, what's the total number? What's the total number here? What's the number here? 34. No, we have 2 numbers here, 34 and 16, right? 34 represents the nucleon number, while 16 represents the atomic number. The nucleon number is always bigger than the atomic number because it is the sum of the protons and neutrons in the nucleus, right? Because while the atomic number is only the value of the number of protons present in the nucleus, so we always expect the nucleon number to be bigger than the atomic number, except for hydrogen, ordinary hydrogen, in which they are what? Equal. That is, hydrogen have 1 1. Why? Because hydrogen has no what? No neutron. Hydrogen has no neutron, so which means that this one is due to the what? 1 proton that it has, right? So apart from hydrogen, for other elements, the nucleon number is always bigger than the atomic number. So the value there is what? 34. The value is 34. Then the next question says, what is the electronic configuration or electronic structure of the ion X2-? Now, note that the electronic configuration, the electronic structure, electronic configuration of an atom or an ion is always based on the number of electrons present in that atom or ion. Fine. For a neutral atom, the number of protons equals to a number of what? Electrons, right? Whereas for a positive what? Ion. For a positive ion, the number of protons is always greater than the number of what? Electrons. Whereas for a negative ion, the number of protons is always less than the number of what? Electrons. Fine. So what is the structure? What is the electronic structure of the ion X2? So first off, what is the electronic structure? What is the total number of electrons of the neutral atom? So from this you can see that the total number of protons here is what? 16. And since this is a neutral atom, means that the total number of electrons is also what? 16. But coming to the ions now, coming to this ion, what do we observe here? The charge here is what? -2, which means that the atom did what? Gained 2 electrons. The atom gained 2 electrons. As you can see here, the number of protons is less by what? 2. The number of protons is less by 2. Remember, to get the charge on an ion, we can use the formula number of protons minus number of what? Electrons, to give us what? The charge, right? So it means that from here, our number of electrons will be equal to what? A number of protons, yes, minus what? Minus a charge. Fine. So from the question given to us, the number of protons is 16, So minus, and the charge on the ion is what? -2. So 16 minus -2, that gives us what? 18. That's 16 plus 2. So it means that the electronic structure we are asked to write will be based on what? 18 electrons and not 16. So for 18, remember the first shell, using our KLM notation, this will be our first shell, will contain 2 electrons, right? While our second shell will contain what? 8 electrons. Now 2 plus 8, that's what? 10. 18 minus 10, 8, right? So you have 8 electrons what? Left. So that gives us what? 288, which is a noble gas configuration. So of course, as you can see, the element or the atom, the element here had to gain electrons to attain the noble gas configuration. Fine. You can learn more about electronic configuration on our video on the electronic configuration using the KLMN notation. We have added the link in the description. The next question says, suggest the formula of the compound formed between aluminium and what? X. Now for the fact that this gives us a negative ion, it means that it is a non-metal, right? Fine. Now suggest the formula of the compound formed between aluminium and what? X. Aluminium, what's aluminium? From our periodic table, we see that aluminium has atomic number of what? 18. It's in group 2. Sorry, aluminium is in period 3, group 3, right? That's 283. 283. And since the number of valential electrons is less than 4, it means that it should always give out electrons, right, to form ions. I mean, that is what? A metal. So aluminum will lose 3 electrons to give us what? Al3 plus, right? Fine. And this X, element X, will lose 2 electrons. Sorry, we'll gain 2 electrons, sorry, to give us what? X2 minus, right? From 16, right? And this is 13, fine. So now when Al3 plus and X2 minus combine, right, what will happen? They'll exchange their what? Valencies. So the valency of aluminum here is 3, while this one is what? 2. So this goes here and this comes here. So that gives us, oh, sorry, this takes this and that takes that. So that gives us what? The formula of the compound will be what? Al2X3. Remember, when writing the formula of the compound formed between 2 elements or 2 atoms, we don't add their ions, we don't add the charges, sorry, we don't add the charges in the formula, right? Since it is a compound, you don't, except we were asked about ions or radicals or something. But since we are only asked to give the formula of the compounds, that it must be what? A neutral compound. We don't need to add the what? Charges. The charges will only help you determine the valency of each what? Element. Fine. And what is valency? Let's write it here. We're not answering this question, we're just trying to define valency. Valency is the what? Number of electrons an atom of an element can what? Lose or what? Gain when it does what? When it combines with itself. When it combines with itself or the atom of another element, and it has no what? Charge. The number of electrons an atom of an element or the atom of an element can lose or gain when it combines with itself or the atom of another element. The atom of another element, right? Fine. As you can see here, aluminium can lose 3 electrons when it wants to combine with the atom of what? X, and X can gain 2 electrons. when it wants to combine with the atom of what? Aluminium. Fine. So let's continue. So now the next question says, what term is used to describe atoms of the same element with different numbers of particles in the nucleus? When we say different numbers of particles, what they mean is that different nucleon what? Numbers, or different proton numbers and different number of what? Neutrons, right? Fine. So when two atoms of the same element, two or more atoms of the same element have different numbers of particles in the nucleus, it means that they are what? Isotopes, or they exhibit isotopy. Are we together? Now, for the fact that they are atoms of the same element, it means that they have the same proton number. So what will now be different? What will now make them have different numbers of particles in the nucleus? It means that they will have what? Different neutron. Now, so let's look at this. We have X here. We have X A, B, and X A, C. Now, since both of them are atoms of what? X, it means that they have the same proton what? Number of protons in the nucleus. So, but here you can see that their nuclear numbers are what? Different. For their nuclear numbers to be different when their atomic numbers are the same, it means that here they have what? Different what? Numbers of what? Neutrons here. The numbers of neutrons of isotope A is different from the number of neutrons of isotope what? B. What term is used to describe what? The atoms, not the phenomenon. So the answer is what? Isotopes, and not isotopy. But if we ask for the phenomenon, exhibited by atoms of the same element with different numbers of particles in the nucleus, the answer would be isotopy. But since the question says term used to describe the atoms of the same element with different numbers of particles in the nucleus, it is what? Isotopes. Identify the atom against which the relative masses of all other atoms are what? Compared. Now, which element is always used as a reference when defining or measuring the relative atomic masses of what? Of other elements. That element is what? Carbon. Fine. I know that carbon has different what? Atoms. Or carbon has isotopes. You have carbon 12, you have carbon 13, and you have carbon what? 14. So the particular atom of carbon or isotope of carbon, or that is always used when comparing the relative masses of atoms of other elements, is carbon what? 12, because of its relative what? Stability compared to other atoms of carbon. So that's carbon 12. Now, what is the name of the amount of any substance that contains 6.02? Any substance, what is the amount here? Amount of any substance that contains 6.02 times 10 raised to the power 23 what? Particles. Now, this 6.02 times 10 raised to the power 23 particles is a very familiar value, a very familiar number in chemistry. This is what you learned in your grade 10, right? In your foundational what? Chemistry, when you just started chemistry, grade 10. So this number is known as what? The Avogadro's what? Number, right? But that is the name of that number. But the question here says the name of the amount of any substance now that contains that, and that answer is what? A mole. A mole, right? And what is a mole? A mole is the amount of any substance. Of course, you can say a mole is the amount of any substance that contains the Avogadro's number of what? Particles, fine. Or we can say that a mole is the amount of any substance that contains as many elementary entities as there are present in 12 grams of carbon 12, right? Now, to learn more about mole or mole concept, you can watch our videos on mole concept. The link is in the description. So the next question says the constant 6.02 times 10 to the power 23 has a name, which I've already mentioned it anyway. The name of the constant is what? Avogadro's number. Avogadro's number. It was postulated by Avogadro, the scientist. That's the name of the Italian chemist that postulated Avogadro's number, Avogadro. That's just by the way. Fine. Is that all? Let's see. No. So the next question, part C of the question says, part of the definition of relative atomic mass is the average mass of naturally occurring atoms of an element. Some relative atomic masses are not whole numbers. Very key. Some relative atomic masses are not what? Whole numbers. Why are they not whole numbers? Because of what? Elements. Because elements are made up of what? Are made up of what we call what? Isotopic what? Mixtures. Or elements are made up of what? Isotopes, simply put, right? Now, that is why this mass, the relative atomic mass, is said to be what? The average, the weighted average mass, right? The average mass of what? Naturally occurring atoms of the what? Elements. So now, here we have element Y with two different atoms, Y69 and Y71, right? For them to be atoms of Y, element Y, it means that they have the same proton number, right? But you can see that they have different nucleon numbers, right? 69 and 71. That's why you are not given the atomic number of what Y, because it's irrelevant here, right? Fine. So the ratio of atoms present in element Y is shown, 69, Y69 and Y71 as well. Now this ratio can also be called what? The relative what? Abundance. The relative abundance of each what? Isotope, right? Of the isotopes, right? So now, which is the proportion of each isotope present in a given sample of the what? Element, right? At any point in time. So now from here, we are told to do a calculate the relative atomic mass of element Y to one decimal place. We must follow the instruction to the letter. So now what we have here, first of all, we must determine the relative abundance of Y69. That is what the sum of this ratio. Sum of ratio is what? 3 plus 2, and that gives us what? 5. So relative abundance of Y69 will be what? 3 over 5, while relative abundance of Y71 is 2 over 5. Now relative abundance can both be expressed as a fraction or as what? Percentage. To express that as a percentage, this will be 3 over 5 times 100, which is what? 60%, while this one will give us what? 40%. But the interesting thing is that by the time you add the total relative abundances of all the isotopes, if when expressed as a percentage, you get what? 100%, and if expressed as a fraction, it will always give you what? 1. Fine. So now, to calculate the relative atomic mass of Y, so RAM, relative atomic mass of Y, RAM of Y will be equal to what? Relative abundance of what? Of Y69 times mass number or nucleon number of Y69 sorry about that, plus relative abundance of Y71 times mass number of Y71. So now what is it trying to tell us? Whenever you are answering your questions or on chemistry, you must always bring your calculator, right? Because there will always be one calculation or the other. So now, relative abundance of Y69 here is 3 over 5. That's 3 over 5 times 69 plus 2 over 5 times 71. So if we evaluate this, what would that give us? That's 41.4 plus 28.4. So that gives us 69.8. As you can see, the relative atomic mass of the element will always be in between the atomic masses or the nuclear numbers of the different isotopes. But see, the nuclear number of Y69 of isotope 1 was 69, the other one was 71. The relative abundance is in between 69 and 71. Now, to learn more about isotopy, the definition of isotopy, the definition of relative abundance, and all forms of calculations on isotopy, watch our video on isotopes or isotopy as a whole. The link is in the description. So you're now told to identify element Y. Now, to identify element Y, we need to go to our periodic table and look for element with relative atomic mass 69 or almost 70. For convenience sake, the relative atomic mass is always expressed as a whole number, except for chlorine that is in the middle, right? So let's quickly go to our periodic table and check. Element 69, 60, 65. Okay, this is 65. After 65, the next one is 70. So 69.8 is almost 70, approximately 70. So the element is gallium. So Y is gallium. Y is gallium. IG always provides the periodic table for its candidate, so there's no need cramming anything, or every information you need is always given to you in the periodic table. So you need to know how to interpret the periodic table, and I've already explained how to know the nucleon number. And the last question here says element Z is in period 3, group 5. Now, for it to be in period 3, means that it has 3 shells, right? It has 3 shells. That's the KL and M shells, right? That's the electrons in the KLMN shells. Now in group 5, it means that it has 5 valence 5 valence electrons. That it has 5 electrons in its outermost shell. So from here now, we can say that the electronic configuration of Z, element Z, will be 2, which, since it has 3 shells, means that the other 2 are completely the first 2 are completely filled. 2, then 8, then the third one is 5, and that's element 15. Element 15, atomic number 15. So if you go to your periodic table, you'll see that the element with atomic number 15 is phosphorus. Let's quickly confirm that. We are here. This is atomic number 12. Group 3. Period 3, right? This period 3. Remember, this period 1, this period 2, this period 3. Period 3, this period 1, period 2, period 3. Group 5. That's phosphorus. Atomic number 15. Atomic number 15, or proton number 15, and nuclear number 31. Explain in terms of electron transfer why Z behaves chemically as a non-metal. Z does gains gains 3 electrons. Z gains 3 electrons to form a negative what? Ion. Remember, they said electron transfer. It means that there is not in terms of sharing of electrons. Electron transfer means that there will be a complete transfer of electrons. It's either it will lose or it will what? Gain. But since it's a non-metal, it's going to what? Gain 3 electrons. So Z gains 3 electrons to form a negative what? Ion. Or we can say that Z ionizes by gaining what? By gaining 3 electrons. Anyone is what? Correct. So what happens here? This is 2 marks, right? So 1 mark for gaining of electrons and the second mark for the number of electrons it will gain. So that brings us to the end of question 1 for the May-June 2020 paper 4. Fine. So in the next video we'll be looking at question 2. So if you're able to learn anything from this tutorial, right, kindly give us a like and drop your comment. If this is your first time here, I can assure you will get more of this. Subscribe to our channel and turn on your notification bell to always stay updated with new uploads. You can also join our membership club to have access to exclusive videos, live chats and live tutorials, right, where you can ask questions on any challenging topic on chemistry and you will always be answered in details. Fine. A wise man once said that the only thing worse than being blind is having sight but no vision. So keep pursuing that dream of yours. Never give up on that dream till I see you when I'll see you.